Welcome, good morning. My name is Asa. I'm the general manager for the Storage Gateway service. And excited to have here with me on screen today Paul Reed, who is the principal product manager on the service, as well as our guest speakers from Bristol-Myers Squibb. A lot of our conversations when we talk about on-prem storage typically revolve around a few key questions I've heard customers run into. They have a lot of backups that need to happen on-prem, don't want to use the expensive on-prem storage infrastructure for backups. Could we be using the cloud to move backups to the cloud? Or oftentimes running out of NAS capacity on-prem, don't want to renew their NAS licenses, but still need on-prem storage needs. Or in a lot of cases, the data is already in the cloud. How can I start accessing that from remote locations? If any of you run into similar questions, you're in the right session here. Today we'll be talking about the Storage Gateway. For those of you that already know the Gateway, we'll give you some key highlights on some of the new features we've launched over the last year, but also talk about some of the use cases so we can tell you how some of the features help drive these use cases that I mentioned earlier. Last week, we introduced a few new features around high availability, more visibility into the gateway, and Paul will go into a lot more details on that. And then we'll hand over the stage to Mohammed and Oleg, who will talk about how Bristol-Myers Squibb has been using the gateway for some of their hybrid workloads. So there's three key use cases that customers use the gateway for. And I'll start with this, and sort of through the presentation, we'll use these themes to talk about use cases, features that help address these key problems. Backup, on-prem storage replacement, and distributed access to in-cloud data. And what we've seen is customers across different stages of their cloud adoption can find use of the gateway to solve these problems. There's often customers that are just starting to use the cloud, and backup becomes an easy way to start moving some of the backup workloads to the cloud. You can take advantage of the durability of the cloud, but yet take big, simple steps to start leveraging the cloud. For customers that are in their migration journey, they can also use the gateway, especially when they're looking at how they move some of their existing NAS capacity to the cloud. And for those customers that have already moved to the cloud, you can still make access to that data available from multiple locations using the gateway. So we have tens of thousands of customers that are using the gateway, hundreds of petabytes of storage managed through the gateway, and petabytes of data being uploaded from on-prem to the cloud. One of the interesting anecdotes I've heard recently from our customers is by provisioning just a terabyte of storage on-prem, they can give access from that storage to customers on-prem, but behind that, they have tens of terabytes of storage in the cloud that they can make available. So they almost save 95% of their on-prem storage needs while not compromising the needs of their applications and users. Thank you. A lot of some of you customers are here. Thanks for all the feedback that has helped make the gateway evolve over the last several months. The Storage Gateway is a hybrid storage service for those of you don't have the initial context here. You deploy the gateway on premises. The gateway makes available standard storage protocols, file, volume, tape. So existing applications can continue to use the gateway without any changes. The gateway provides a local cache, so it's frequently accessed data can be available with lower latencies on-prem. It optimizes the data as it's sent between the gateway and the cloud. So it makes best use of the bandwidth over the network. And then once the data goes into AWS, we can store it into multiple storage services, either S3, all of the storage classes within S3, or EBS snapshots, et cetera. And the gateway is integrated with a lot of standard management and monitoring frameworks, CloudWatch, CloudTrail, tagging. So you can basically monitor and manage on-prem gateways just like you monitor any AWS service. Within the Storage Gateway family, we offer three types of gateways. The File Gateway provides the file interface to data that's stored and retrieved in Amazon S3. We have both NFS and SMB protocols. ACLs are maintained, so you can keep consistency between on-prem access needs and the data being stored in the cloud. The data managed through the gateway is stored as native objects in S3, so you can run your existing object-based workloads on the data as well, so you essentially have multi-protocol access to data. And there's a one-to-one mapping between objects and files. The volume gateway is our second type of gateway. It provides a block interface. So you have an iSCSI protocol interface, block-based applications right to the gateway. And on the back end, the volume gateway data is maintained within the storage gateway service. We store it in S3 as blocks. But you can then make EBS snapshots out of this data, or you can then convert volumes, and so you essentially can use that to recover your data or access it from your EC2 instances as well. The tape gateway is the third type of gateway. We offer a virtual tape interface, where essentially you can convert your physical tape-based workloads to virtual tapes in the cloud. It works with all standard backup applications, so you don't need to make any changes to backup workflows. And the data can be maintained in a virtual tape library in S3. And when you archive the tape, you can move those archives into either Glacier or Deep Archive. In each of these three types of gateways, we've announced a number of new features over the last 12 months. I'll just give you some quick headlines here. So for file gateway, we introduced support for object locking, so you can now have more compliance or regulatory workflows that need that data to be saved in S3. We've invested in improving the performance of the gateway, so you can now read and write up to 4 gigabits per second on each gateway. We also just a couple weeks back introduced an increase in the directory read performance, so your metadata access can be faster as well. On the volume gateway, earlier this year, we integrated with AWS Backup. So snapshots that are created and managed through the gateway can now be controlled through AWS Backup, much like your other in-cloud backup needs. So it gives you a single pane of control between on-prem and in-cloud backups. On the tape gateway, we've continued to add support for multiple backup applications. We announced support for IBM Spectrum Protect a couple months ago. We also increased the size of tapes that can be managed from 2.5 to 5 terabytes. So you can manage more data with fewer tapes, just makes it easier to manage backups. And much like file, we've also invested in performance increase. We got almost a 3x improvement in read performance for the gateway, which we announced just last week. Continuing to add regions, the storage gateway service is available in 20 commercial regions, including GovCloud and Beijing. Some of you might remember we announced the hardware appliance support at reInvent last year, so the gateway can run both virtual and hardware configurations. This year, we made the hardware appliance available in Europe as well, and increased the size of the cache that you can maintain on the hardware appliance from 5 to 12 terabytes. And Mohammed and Oleg will talk about how they're using the hardware appliance for some of their workflows later in the presentation as well. A big theme for us for this year was investing in more enterprise features, so more performance, more availability capabilities. We've also continuously heard an ask from customers to get more visibility into how the gateway performs. So you can use that to tune workloads, to monitor memory or CPU utilization. So we introduced a whole set of CloudWatch graphs that you can access from the gateway. And Paul will be going into more details on both those features in his part of the presentation. Also, just a quick thing, the hardware appliance we introduced in partnership with Dell. So we have a promotion, thanks to the partnership with Dell, where there is a discount on the price of the appliance for the next few weeks. And you also can get credits on the data transferred through these appliances. So talk to us more if you have more questions on this later as well. So I'm going to focus a little bit on the 3 use cases that I mentioned earlier, and how the features of the gateway help make these use cases simpler to use. So the 3 use cases, again, backup, on-prem storage replacement, and content distribution. So let's look at the backup use case in a bit. All 3 types of gateways can be used for different types of on-prem backup. So from on-prem applications, you might want to back up files, you might want to back up your databases, or even tape-based backup workflows. So the 3 types of gateways can help no matter what backup needs you have. And in all of these cases, the data gets moved into AWS, so you have the benefits of the durable data stored in AWS. And in most cases, you can restore and recover the data in cloud as well. So let's look at the file gateway. So a number of backups like databases or applications oftentimes use scripts or in-application mechanisms to back up that data. And customers traditionally write that data into file shares. So we have a number of use cases where customers are now writing data from these databases, SQL Server, Oracle, RMAN, et cetera, into the file gateway. And the data then gets moved into S3. Because the data is available as S3 objects, now you can create an in-cloud database, either through an EC2 self-managed database or even an RDS database instance, and you can restore that data to the cloud. So this becomes a first step towards eventually migrating the database itself into the cloud as well. Earlier this year, we introduced ACLs on SMB file shares, so that way what we've heard customers do is put more granular controls in the data that's backed up through the file gateway. Volume gateway, as I mentioned earlier, we integrated that with AWS backup. That allows you to control the retention of your snapshots. And again, the volumes that are created from volume gateway can be restored in cloud. So you can not only back up that data, but achieve recovery and restore in AWS. We had a deep dive session on tape gateway, which talked about a lot of the internals of how tape gateway works. But the key point to remember is the advantage of tape gateway is you can continue using tape-based backups. But instead of keeping virtual tapes, managing the recycling of these tapes or moving them off-site to archives, through the tape gateway, you can move them into virtual tapes in AWS. So Analog Devices was one of our customers. They spoke with us last year. They were using EMC Networker. And for a period of 6 to 12 months, they did a parallel backup. So they were backing up their tapes through the tape gateway into the cloud, as well as through their physical backups. And they would alternate their restores between the two to get comfortable on their restore process. And just a few weeks ago, they completely turned off their on-prem backups, and they've moved everything to the cloud. And in the process, they've achieved at least a 50% reduction in cost and having the durability of storing that data in, especially in their case with Deep Archive. You get basically $1 per terabyte tape stored in Deep Archive. Kellogg's, they use the file gateway for backing up their databases, so Oracle and SQL Server databases. Again, in their cases, they backed it up through the gateway, and now they're recovering that data through EC2. And in their particular case, they were able to eliminate the need for backup applications because they're just writing scripts that back the data into the file shares made available through the gateway. Let's move to the second use case. The second use case is about using the gateway to shift on-prem storage from existing NASes through a cloud-based file share. And I'll talk only a little bit about it because Bristol-Myers in their presentation will go deep into how they've been able to use it for this particular use case as well. But essentially, what we've heard from customers is, you run out of capacity on the NAS, or you want some workloads that don't need the high-end performance can write that data through the gateway. And the key features here are having access to both NFS and SMB protocols means applications don't need to change. And you then get unlimited access to data, so you're not constantly worrying about capacity management. We did a chalk talk we're doing one tomorrow actually with Cox Automotive, who was describing this particular use case on how they've moved some of their data to the cloud through data sync, and they're doing some of their writes through file gateway to basically eliminate some of their on-prem storage. And in their case, they're saving, again, 80% of their on-prem storage costs by leveraging cloud backups. The third use case, which we've seen an increasing number of customers use, is around content distribution. So oftentimes, data is moved to the cloud either through data sync, Snowball, or in some cases, the data is produced as a result of in-cloud processing. But there is a need for sharing this data in remote locations, either branch offices, remote offices, or because researchers or access for that data is required on-prem. And in this cases, customers deploy multiple gateways in different locations, and they use this feature called refresh cache, where you can keep all the caches continuously synchronized with the changes that happen in cloud. And this allows you to distribute that data across multiple locations. CME Group have presented their example of using their financial calculations. They're doing that in the cloud and making that data accessible through gateways. And so end developers can keep using their existing applications to access the data through file-based protocols, but the data is all stored and maintained and updated in the cloud. So I'm going to switch over to Paul, who will go deep into some of the newer features that we've introduced a couple weeks ago.
Thanks, Asa. So I get to do the fun stuff, the stuff we just launched, which is always super exciting. So Asa mentioned that more and more customers are starting to use the gateway for more and more workloads. And as you start to use the gateway for more and more business-critical workloads, obviously you need the gateway to be more available. You can't suffer a loss. You can't have your storage go out on you. So in order to meet that, we've added this high availability feature for VMware. The majority of our customers today use VMware. We also support Hyper-V, EC2, and the hardware appliance. But today, the bulk of our customers are using VMware, so we started there. Again, if you're starting to use the gateway for these more critical workloads, you need insight. You want to know what's going on with the gateway. So we've added additional sets of metrics to provide visibility into the performance of the gateway and the health of the gateway and how it's working. Now, the gateway is an appliance. It's either a hardware appliance or a virtual machine. And so there's software running on the gateway. And so we have to provide maintenance patching of that software to keep up with security patches and add new features, which means the gateway needs to recycle. It needs to restart periodically. And so, again, once the gateway starts to get used for more critical workloads, knowing when the gateway is going to restart, which may cause an availability issue for your applications, is super important. You want to be able to manage when that can happen. So we've added additional controls that allow you to specify when the gateway should take those updates to align with your maintenance windows. And I'll go into all three of these features in a little more detail. So the first feature that we added is high availability for VMware. And so this is an integration with VMware's HA capability, where the gateway has a heartbeat and it has checks that are running that integrate with the underlying hypervisor in order to provide heartbeating such that if the gateway has issues or has problems, or the hypervisor has problems, or the virtual host on which the gateway is running has problems, the gateway will be, a second gateway will come into being and will take over from the first, and not interrupting your application and giving you that availability that your critical applications need. So this protects you from both hardware, software, and network errors, and provides effectively an always-on capability. So let's look at the three scenarios that can happen. First is software failures, software crashes, things happen. What will happen is the underlying hypervisor will see that the application heartbeat has gone away and will spin up a new instance of the gateway for you transparently to your applications that'll pick up from where your application left off. Again, in most environments, using shared storage, so your cache and all of your data is totally integral, totally safe, and your applications don't even really see the handover that VMware does for you. Hardware failure happens similarly. In this instance, you're going to come onto a new VMware host, and again, your applications are going to not see anything happen. They're just going to see a new gateway that's got the same IP address, and they're going to keep working. The third is sort of the disaster scenario where your entire data center fails. In this instance, again, what VMware is going to do is he's going to fail everything over. He's going to fail the gateway and your applications over to the other data center. And again, things will continue running as you expect of mission-critical applications. So a really nice feature integrated deeply with capabilities of VMware that your admins already know and use. And now the gateway works with that seamlessly. Now, in order to provide you insight as to what's going on, we've added a whole series of CloudWatch metrics. Again, CloudWatch being our maintenance and monitoring tool. So we've added a series of metrics that, for anybody that uses EC2, may be very familiar, metrics around the gateway's usage of its underlying virtual hardware, as well as some of these HA capabilities, and the existing metrics that we had around cache utilization and data transfer. So let's look at what this dashboard looks like. So if you come to our console now, there's a new monitoring tab against your gateway. We present all these nice CloudWatch graphs in line within the console. Let's look at some of those graphs in particular. So here's our traffic graphs. This is showing you data. AV? Nope. back, thank you. This is showing you data, client traffic. This is data from your application coming into that NFS, SMB, or iSCSI target. Coming into the gateway, that's the first graph on the left. The graph beside it is then showing the data going from a gateway that gets asynchronously uploaded to the cloud. So what you'll see is the red line on the graph on the left are writes coming into the gateway, so it's application maybe doing a backup or writing data. And then on the second graph, the green spikes that correspond to the red spikes are the data going uploaded. So you see a very healthy gateway here. You've got data getting written to the gateway, and then data getting uploaded to the cloud asynchronously. This is what we'd expect to see. You see nice correlations of these reads and writes, or reads and uploads, rather. The second set of graphs here show you about the cache. Again, when you write data to the gateway or read data from the gateway, you're really interacting with that local cache on the gateway. And in doing so, we're going to cache data and then upload it to the cloud. So what we're seeing here are a series of graphs that show how much data is coming out of cache. That's one in the top left there, which is cache hit percent. You expect that for normal workloads to sit at about 100%, right? You always really want to be interacting with data in the cache because that's local to you, that's on-premise, it's on your premises, on your LAN effectively. Now, every now and again, you'll get a cache miss, and that's where you see that spike drop. Many customers set a CloudWatch alarm on these, so they want it to sit at 90% or something because they want data in their cache, and if cache hit percent drops below that for an extended period of time, their application is seeing increased latency of having to pull data from the cloud, and so they potentially look at increasing the size of the cache to handle the working set of their application. Cache percent dirty there, the graph on the beside that, you want that to sit at 0. 0 is a good number. Data in the cache that is dirty is considered not uploaded. Again, our gateway, when we looked at the traffic, was quite happily uploading data shortly after it was written, and therefore that data in the cache is now clean. I can evict it. It's clean. It's safely uploaded to the cloud, so you want that to sit at 0. So again, setting an alarm there at maybe 10% would give you an indication that your gateway is a little bit unhealthy because you're not uploading data to the cloud as quickly as you would like to. So customers have these CloudWatch alarms to watch for that occurrence. Index cache is a new metric that we added that shows data in the metadata cache of the gateway and how that's being evicted. So again, the gateway is going to try and present a file system to your applications, and in doing so, it needs to have a metadata cache so that when you do a directory listing or look at the attributes of a file, that data is immediately accessible to your application. Downloading that from the cloud each time is not what file-based applications expect, and so we show you that cache and how that cache is performing also. Again, moving on to some of the newer metrics that we've added. Many customers that are running, say, a file gateway using SMB like to know that all of their clients are using the latest version of SMB, right? They're using SMB3, it's nice and secure, it's safe. So now we track SMB sessions, and we'll show you by SMB version how many clients are attached to the gateway. So you can now track, oh, look, in here my red line is SMB v1. So I've got a legacy client all of a sudden came on there using an older SMB protocol that maybe I don't want in my network. And so I need to go hunt down that older SMB client who's not using encryption and not using some of the latest parts of the SMB protocol that you prefer on your network. Again, for anybody that's running EC2, we now provide memory and CPU utilization. Again, you can set thresholds on these, and it allows you to watch the health of your gateway. Maybe your VM is running out of capacity, or you've got over-provisioned hardware, and so your memory or your CPUs are being overcommitted on your hypervisor. So this gives you an indication to show how the memory is being used and how the CPU is performing on your gateway. And then last but not least, a health check. So again, VMware HA integration provides health checks, and so this is showing you when the health checks have kicked in and caused your gateway to have to do a failover to that standby. Let's look a little bit more at CloudWatch integration, because again, over the last year, we've made a number of feature enhancements here. So the gateway is integrated with CloudWatch, and we send a number of events. Those are CloudWatch events, so you can trap those and use things like SNS or send email or trigger a Lambda. There's 3 particular events that we send in the bottom left here. So upload notifications tell you when that data that you wrote to the gateway has asynchronously been uploaded to the cloud. So if you wanted to trigger a workload, for example, and know that that data is safely stored in S3 or available to your in-cloud workload, you can trap that CloudWatch event for upload notifications. Asa mentioned refresh cache. So again, the gateway is going to cache data fairly aggressively to provide that low latency access to data. But if you have an application that's writing to your S3 bucket, you need to tell the cache that there's new data in the cloud that it needs to refresh in its cache and get a sort of an updated view of that bucket. And so if you tell the gateway to refresh cache, you want to know when that data is available to your application. So we'll send you a notification to say, yep, the gateway now has an up-to-date view of your S3 bucket. And so again, you can trap that with a Lambda and trigger a downstream workload. Then the last one that we've added recently, we mentioned S3 storage classes. If data is lifecycle down to Glacier, it's obviously not accessible. If you go directly to S3 and try and get an object get an object that's in Glacier, you're going to get a response from S3 that says it's in a storage class that you can't read immediately. You're going to need to transition it back to standard or an infrequent access tier. Now, obviously, those semantics don't exist for file-based applications. You access an object that's backed by a Glacier, or a file that's backed by a Glacier object, and your application just can't read the file. You'll effectively get an I/O error, because that's all we can give with something like NFS or SMB. But we have customers that want to be able to use that storage class and then transition those objects back up so that their file-based applications can now access them. So what we added was a CloudWatch event that anytime a file-based application accesses a file, which is backed by an object that's in Glacier or Glacier Deep Archive, we'll send you a CloudWatch event telling you what that file is that the application tried to access and got an I/O error on, which allows you to then hook that to, say, a Lambda to retrieve that object back up into standard where your application can now read the file. Again, retrievals have a cost, so this allows you to manage the cost of those retrievals and the timeliness of those retrievals within something like a Lambda, so you can codify your own business logic in order to do that. So a super important feature to allow you to use all of the S3 storage classes and make good cost-effective use of the cloud storage while still maintaining file access to that data. And the third feature that we've added recently is maintenance window management. Again, the gateway is a VM or a hardware appliance that runs software. Software needs patching, and so we put controls into your hands to say when you want those patches to take place so that you can manage around any potential availability of the gateway restarting or components of the gateway restarting that might disrupt your application. Again, our restarts on the gateway, we've done a lot of work to make those super fast now. So in general, they happen within the iSCSI or NFS or SMB timeouts, so your application won't even see the restart. But just in case your application is maybe disrupted by that or is super latency sensitive and won't live within that timeout, we allow you to manage and control when these maintenance will automatically happen. Now again, I want to point out that if you want to manually apply maintenance, if you want to manually apply software, you can do that as well. We have an API that allows you to, say, apply software now. But for many customers who are running lights-off environment, they rather prefer this automated mode where they know the gateway is constantly being kept up to date, but on a schedule that you control so you can manage around when the gateway might restart and when those availability issues might occur. With that, I'll hand over to Mohammed from BMS. Thanks, guys.
Good morning. I feel humbled and privileged to talk about our hybrid cloud journey and also talk about the work of our many IT folks and scientists in delivering this digital capability. But first, a word about who we are, what we do. Bristol-Myers Squibb is a biopharma company with a mission to discover, develop, and deliver innovative medicines to our patients to manage serious diseases. So we offer drugs in oncology, immunosciences, fibrotic diseases, and as IT, we support our scientific community. So a little bit about the inspiration and passion behind our work, right? Bristol-Myers is very focused and very patient-centric in all the work we do. So is IT, right? We every day we think about our patients, how we can enable science, how we can help our scientists get deeper insights into biologics and biology data, right? And as you know, cancer has touched all of us. So the fight against cancer is global. All of us are involved in some way. And we are very proud to have AWS as our partner. We use AWS cloud services for all our compute environments and getting scientific insights So today we'll talk about our hybrid cloud journey, but focus more on AWS Storage Gateway appliance, right? It's all about data. So as you see, the data in the last 3 or 4 years have grown exponentially, right? Typically generating hundreds of terabytes a year, now we are talking about tens of petabytes, right, in a relatively short period of 3 years. So what drives this kind of an exponential growth, right? So scientific data, biological data is very complex and very large scale, right? The cost of sequencing genes have gone down exponentially, right? And which means sequencing, DNA sequencing, whole genome sequencing, exomes, RNA sequencing, proteomics is now core of how we understand science, biology data, and help discover new medicines, right? So a lot of data is generated in the lab. We also get clinical data, patient data from external sources, right? So today we have many scientific domains or workflows using hybrid cloud, right? Next-gen sequencing proteomics is a very large-scale use case. Flow cytometry and imaging data is very complex data sets. The data comes in different formats, and to analyze it requires a lot of compute power. And today we are also using machine learning to understand and get more insights. A little bit more on the technical side, right? So raw data generated in the lab needs to be sent to cloud or ported to cloud before we can process, analyze, and derive insights out of it, right? So an AWS storage appliance plays a critical part in how we move the data. In fact, we use many of the services that to move the data. We use Snowball, we use Snowball Edge, we use SFTP, and now AWS Gateway Virtual as well as the appliance, right? Once the data is on the cloud, we need to create a catalog, right? We need to catalog it, index it, right, before we send it downstream for analysis, right? So we use gateway appliances today for moving real-time or near real-time data into cloud for analysis. The second one is once we get there, many servers, EC2 instances or clusters of EC2 instances are used to compute and analyze the data sets. We use what's called as scratch space. Scratch space is simply a term we use for temporary storage, which requires high IOPS, right? And of course, when we get results data, we need to share it, between applications, between scientists, and externally. We use EFS storage to host our results data. And of course, external collaborations and many public and government agencies are sending us a lot of data sets. So putting that data directly on S3 makes sense, right? So what makes the data complex? What are the challenges in handling biology data, right? So it is not just the scale, it is also the velocity. The number of instruments in our labs all over our discovery centers are generating tens of terabytes a week, right? So it's how fast we get the data. The data, of course, is of different formats, especially when it is pathology data, histology data, image data, high content screening data. These are all proprietary specific formats. So you need to convert them before you analyze. So a different type of challenge there, right? On the technical side, the instruments only understand NFS, right? So the problem with that is it is only POSIX metadata, right? So limited metadata is there on the files. The scientific data, operational data, business data need to be kept into databases. So when we move the data into cloud, we have the need for enriching, because once you get into object storage, you can add tags. You can add business tags. You can add scientific information in there. So enrichment is a process that takes some time there, right? So hopefully, Andy Jassy announced Outpost, S3 Outpost yesterday. We are eagerly waiting for it. I think this would help us get to the next stage. So coming to the hybrid file use cases, there are many. We'll touch a few today, right? And the hybrid file use cases come in many flavors based on the scientific domain and the data type. But what is common between all these workflows is data transfer needs, right? That's where storage gateway appliance comes in. Tools to analyze the data. Many tools are specific to the business domain. And of course, now we are using machine learning to get even deeper insights. So lab to cloud is an initiative where we are putting in all our imaging data and our genomics data generated in the labs into cloud, right? What is required once it gets there? Our metadata catalog, you need technical information in there to know and provide logistics of file movement. And then you need a business domain specific metadata which hosts the business or scientific information in there, right? We also use graph databases to understand the relationships between the data. And then downstream, we push it to data lakes for analysis, right? Machine learning is key to some of the workflows. Flow cytometry is one of them. Flow cytometry is a laser-based microscopic cell-level data, right? And today the technology, it's a technology which is 30, 40 or more years old, but the newer technological advances has allowed us high parameter flow cytometry at a cellular level. So which means that what we see is millions of events in a sample. So we are talking about 10 million events in a cell sample. So how do you label them? How do you tag them? You cannot. It's a big problem. So we cannot use supervised learning models. So in this case, we use unsupervised learning models, proprietary algorithms to understand and visualize this data. So before the ML was possible, machine learning was possible to analyze this data, we used to downsize the data sets. So you only look at the specific areas of interest. But today we can see all of the activity, a much larger activity, right? So ML has been very, very, very instrumental in getting insights because you get visual images of the entire activity in there. Image management is another use case for hybrid use case, but it's a different use case. Image management is large files, and they come in different formats, right? So radiology data is DICOM formats, and many instruments have very specific data formats. So what do you do with it? So you need conversion before you analyze. So downstream analysis is only possible after you bring it into a common JPEG or a TIFF format. So what does a typical workflow in a hybrid cloud looks like, right? So scientific instruments generate lots of data in the lab, right? That data is hosted locally on NAS storage because of NFS limitations. Most instruments today can write only NFS-based files. That is changing. Some of the newer genomics instruments can write object as well. So we are looking forward to using object storage to process that. So once we have the data on the storage, local storage, we need to move it to cloud. So file gateway is what we use over AWS Direct Connect. And once it lands into S3, we need to organize it, capture it in metadata catalogs, index it, and get it ready for downstream analysis. We also do the enrichment process here, since we also we have to move our database or data in our local databases there for the enrichment process. And downstream applications are either specific applications for visualizations, or goes into our data lakes, which then uses several different visualization tools. So a little bit more into how this is configured, how it is done, right? So as you see, multiple instruments generate a wide variety of formats and large-scale data sets, right? So we use Snowball to get our legacy data sets into cloud. We use AWS Storage Appliance to move the data. We also use data sync. We also use SFTP processes, right, over Direct Connect. But what is special about AWS Storage Gateway Appliance, right? So there are three things that are very applicable to hybrid computing, right? One is the onboard cache. What onboard cache provides you is the asynchronicity with our instrument workflow, since instruments cannot direct write and the onboard cache is also very small, right? And the asynchronicity will decouple the process of capturing the data and moving the data. So it is, capture and then dispatch. The second thing that Storage Gateway Appliance provides is the automation. It will convert your NFS to S3. It will compress. It will encrypt the data. And it is an automated fashion. AWS does all the work, so we don't have to do that, right? And third is our local applications can also access the data when the files are mounted on the application server on-prem. So once the data get into S3, there is a lot of work before we even process it, right? So in the case of image data, we need to convert it. So the conversion process is an external process to this workflow. So there is raw data capture in S3, cataloged and indexed, and then sent for conversion, brought back into S3, and then it flows through the analytics softwares. In the case of genomics, we use genomics ontologies, graph databases. In case of image data, we have custom software to analyze, to stitch the images together, and then see it. And the data then ends up in the data lakes, right, for users to query, analyze the data. So with that, I want to hand over to my colleague, Oleg, to go over the details of the configuration of the gateway appliance, the lessons learned, and what do we expect from AWS as we mature this appliances into our next version, next level. Oleg.
Thank you, Mohammed. Good morning, everyone. As you have seen, AWS Storage Gateway plays a vital role in many important applications by Bristol-Myers Squibb, especially where data transfers from local lab to cloud is involved. I'm Oleg Mosenko, Senior Cloud Architect at Bristol-Myers Squibb, and today we continue our presentations how my company engaged Storage Gateway, highlighting some important technical and business outcomes, as well as few lessons learned. To me, there are three main reasons for such a great success of this service at Bristol-Myers Squibb. They are, of course, efficient data transfers offered by Storage Gateway, great cost and elasticity, and overall simplicity of this service. Indeed, pretty much anyone in this room today with just a few mouse clicks could deploy Storage Gateway from AWS Web Console and start using this service literally in minutes. Thanks to a great file sharing capabilities offered by Storage Gateway, you could continue to use your legacy applications in cloud, effectively presenting S3 storage space as a standard file system. Despite of many other great advantages by Storage Gateway, this functionality alone is huge because it allows you to continue to use your old legacy applications in new cloud platforms with zero changes. We love it. This is great. But before I continue on Storage Gateway, please let me allow to highlight the importance of good planning for successful Storage Gateway deployment in your company. First of all, you will need to pay attention to S3 buckets configurations and access policies. You also advise to take a look in naming conventions of your data you want to transfer with help of Storage Gateway to S3 side. We recommend you don't use spaces and special characters in file names. And also, you provide detailed mounting instructions how to mount Storage Gateway file shares for end users who will be using Storage Gateways. In case you want to use some data management system after your data have been transferred to S3 side through Storage Gateway, you need to think in advance about collection names, access to metadata catalog, and develop good and reliable metadata tag systems. As many of you already know, today's Storage Gateway comes in two main implementations. One could deploy this service virtually in cloud, or you could deploy it locally in your data center. The latest option is called AWS Storage Gateway hardware appliance. And the biggest advantage it offers is low latency for your applications hosted locally. You could deploy AWS Storage Gateway hardware appliance in 5 easy steps. From Amazon console, first of all, you request hardware appliance in configuration what seems to be right for your project. Then, of course, you purchase this appliance, and when it arrives, you rack it in, complete cabling setup, boot it up, and establish connectivity to your new appliance. After that, you should be able, from Amazon Web Console again, activate this appliance, adding type of gateway you want to use on top of hardware Storage Gateway. On the configuration side, besides S3 access policy already mentioned, Storage Gateway appliance will require additional IP addresses, few proxy and firewall settings. The main advantages of Storage Gateway hardware appliance to us are complete ownership and, as I already said, with low latency. Of course, when you access your S3 data set from hardware appliance very first time, eventually there would be some delay because behind the scenes, Storage Gateway needs to retrieve your data set from S3 object store. But after that, all other calls to same data set will be served from Storage Gateway hardware appliance cache in single milliseconds. Based on our experience, we also recommend you engage AWS Direct Connect link with Storage Gateway appliance. This way, great data compression offered by Storage Gateway combined with consistent network connectivity of AWS Direct Connect line will result in overall positive user's experience in your company. The main lessons learned on AWS Storage Gateway usage for us are, first of all, you need to pay attention to network configurations. You also want to do live testings from actual scientific instruments before going to production. It's important because each scientific instrument has different activity patterns, and you need to test this carefully. And last but not least, you need to execute extra caution while sharing same S3 buckets through multiple storage gateways. Why is that? Because in this case, storage gateway A will remain unaware of any changes done to your S3 buckets from storage gateway B. And in order to remediate this situation, you would have to execute cache refresh API call for storage gateway A. And this call, depending on size of your S3 dataset, might take a while. Elegant but simple solution how to escape situations like this is you engage S3 access policy what prevents any changes to your S3 bucket, but for a role used by storage gateway. On this sample S3 access policy on a screen, we explicitly deny delete object and put object actions for anyone but user with user ID test user. And this brings us to the end of our presentation. To quickly summarize this, Bristol-Myers Squibb's engaged storage gateway for multiple workloads when we want to move tons of scientific data from local labs to cloud. And all this time, storage gateway works efficiently, reliable, and cost-effective for us. Fortunately for us, AWS Amazon doesn't stop here, and while we continue to use storage gateway, we also look in other great services from Amazon storage portfolio. I'm talking about services like AWS SFTP, AWS Data Sync, and few others. Data Sync especially looks attractive for anyone who wants to move data from local premises to cloud and doesn't care about file sharing capabilities offered by storage gateway. Ladies and gentlemen, thank you so much for your time and considerations, and let Mohammed and me know if anyone has any questions. Thank you.
So thanks, everybody, and thank you very much, Oleg and Mohammed. So we told you a little bit about Storage Gateway as Service. We've given you a little insight into some of the newer features that we've added over the last year, and most recently, some of the features we added in early November. You've heard a little bit from one of our customers about how they're using Storage Gateway. So I'd encourage you to go home, try it out. As Oleg nicely mentioned, super easy to get going from the AWS console. Click and download the VM, deploy it, and you're up and running in a few clicks. Thanks for coming, and if anybody has any questions, please stick around. We'll take questions on stage if anybody needs it. There's a bunch of other sessions going on around Storage Gateway for anybody that's still got time this week on their schedule. And thanks.